sharing the aspirations of Elon Musk and the exploration of Mars and other space bodies. I want to help him with my startups. After analyzing the deplorable state of the launch pad after the launch of Super Heavy, I had to temporarily postpone the presentation of my many years of work, my interplanetary ship, and urgently deal with the startup. Marcus House showed the design of the plate under the launch pad with a huge number of valves. Frankly, I was surprised by the project of impact damping in excess of the high temperature pressure of gases, with a pressure of 7.5 thousand tons per 100 square meters in dynamics. That is, the dynamic combustion impact is approximately equal to 75 tons per square meter. At the same time, creating an area of reflected, chaotically increased pressure directed towards the engine nozzles, causes a decrease in their thrust and unpredictable vibrations. Gases must be removed, and not prevented by a wall. The behavior of the water valves operating in this facility and the chemical purity of the water used in this system is unpredictable. In such severe conditions, the water must be distilled. Otherwise, the valves will instantly overgrow with scale. Based on the animation of the project by Marcus House, the valves are raised, opening the passage of water jets. But the pressures of the incoming blow, given the surface area of the valves, will have to slam them shut. The huge infusion of water into the flame of the vortex of exhaust gases is also doubtful. The pressures and speeds of their crossings are simply not comparable. As a result, the water will simply be thrown out of the core without completing its main task. In your initial project of the launch pad, there was a traditional metal gas-vented flame deflector, used on the FAU-2 and replicated all subsequent ballistic missiles in the world. I suppose that the rejection of this project occurred due to the impossibility of maintaining sustainer engines, their power and control systems. In my concept design for upgrading the Super Heavy launch pad, I try to create a working model, bypassing almost all the flaws in your design. The uniqueness of the structure lies in its aesthetics, universal multifunctionality, compactness and global performance of the main launch functions. In the artificial cooling of the body of the flame arrestor during the entire launch and change in the direction of the jet due to the Templin configuration of the segment design. In a multi-segment, depending on the number of supports number 5, the configuration of the flame arrestor unit has two positions in terms of startup and maintenance. The change of position occurs due to their self-propelled movement by means of rail movement, provided by an electromechanical remote control drive. The segment itself, number 2, is a welded structure. The sides are made of sheet steel of small thickness, having power temperature transmitting bulkheads with bypass holes number 23. The steam generation system is designed for any, including seawater. Therefore, there are hatches in the segments for their periodic cleaning from salts and alkalis. The upper flame-burning sheets of the springboard are made of steel of considerable thickness, welded with an overlap of the upper sheet over the lower one, with a lack of penetration in the middle part of the width of segment number 20. The gap formed is the steam outlet nozzle. When starting, the nozzles are under the flow of the gas jet, due to which a reduced pressure is formed in them, which increases the speed and volume of steam escaping from them. Superheated steam creates a flame-extinguishing cushion from below, reducing surface heating and pressure in the segment. The shape of the segment forms the direction of the gas jet, turning it upwards in a trampoline way. The launch site must have an underground water supply network with feeder outlets to the outside number 26, coupled with corrugated hoses number 19 of the segments in a flattened state. In the retracted state of the segment, the corrugated sleeve is suspended on a rod with a ring hook device. Before the start, the segments are filled with water up to the bottom nozzle number 12, and at startup pumping is constantly performed, providing abundant vaporization number 17. The segments move lighter without water. When the segments are separated, the pneumatic platform for servicing Super Heavy number 6 engines opens. One segment drives off to a longer distance, sufficient for free entry and exit of special equipment number 24. When lifting the pneumatic platform, the floor clamped on the springs is released, forming a flat surface under the pneumatic platform number 25, regardless of the height of the platform. With the final decision to launch the product, the pneumatic platform is lowered, pressing the floor into the well, allowing the segments to move in the center of the platform. Then the platform rises to the stop with the bottom of the segments, dressing with holes number 13 on the pins of the bottom of the segments number 7 forming a lock connecting all the segments into a single block from above. The resulting cone is connected with a ring of any configuration number 21 cone, made of heat-resistant metal. Shields are tightly installed around the supports, covering empty spaces, providing tolerances and landings for the longitudinal movement of segments number 16. They have cooling similar to segment, only stationary.